You're right. You can disconnect the phone. Right? So we can
Yeah.
disconnect it. Again,
Hello all. Welcome to today's session. Today we are going to learn about raw data to revenue end-to-end ML mastery class. Okay? Are you ready for that? I'm waiting for your response. Okay, good. I'm getting messages in the chat. Okay. So in today's class, we are going to learn about these are the topics. Is it visible?
good. I'm getting the messages in the chat. Okay. So
Okay. In today's class, we are going to discuss about what is ML and what are the steps we need to follow for designing ML and ML model evaluation. So, what are the outcomes we are expecting from this? So, after end of this session, you will get fair idea about systematic data analysis, how to design the model, after that how to evaluate, what methodologies you have to apply on real objects. So before starting this session, I wanted to know it from you. What is the definition of machine learning? Can you write it in the chat? Please write it in the chat. Yes, the definition of machine learning is nothing but we have to build algorithms. Okay, so what is our goal? We need to build the algorithms. To build the algorithms, we have to follow one strategy. What is that? Learn patterns from the data, and once we have learned some patterns from the data, we need to go for the predictions. So, what is our target? We need to come up with predictions. Our target is for prediction. This is my target. So to reach this target, what I want? I want algorithms. To design these algorithms, what methodology I am following? I am following learning the patterns. In the coming session, I am going to discuss what is this learning pattern, what type of data I have to consider, how it is different from rule-based approach also. These things I am going to cover. After covering theory part, I am going to discuss on data set. Using that data set, how to develop one ML program also. Then how to come up with that evaluations. Okay. So this is the definition. This is known definition and it is not giving any panic attack to us. Just simple definition. Algorithm building. Okay. To design this algorithm, I require the data. I'm not taking normal data. From the data, I need to get the patterns. Why? For getting the decisions. Okay, so using this use case, are you getting idea using the definition, are you getting any use cases where I have to use this one? What are the use cases are required? Where prediction is required? Use cases in the sense where predictions are required. Think about it. Where we have to apply? Some predictions are required. So we came to know that from the definition, we came to know that ML is an algorithm. From that algorithm, what we are achieving? We are going for prediction. For this prediction, I am taking the data. but data is not in a normal format. In a particular pattern I want. In a particular pattern I want. We have to think use cases in this direction. Okay, based on this direction, what are the examples or what are the use cases? First one, okay, before starting this one, I will tell you real time use cases. Tomorrow I want to visit Charminar. Okay, I want to visit Charminar. So not today, tomorrow. Okay, tomorrow if I want to visit this Charminar, what I have to do? First, I check tomorrow's temperature. Okay, weather forecast. Okay, what I'm doing? I'm forecasting the weather. Based on that weather forecast, it may be sunny, it may be rainy. Based on that, I have to carry umbrella or I have to carry cap. I'm going to decide. See, in real life also, we are using this prediction when if I want to visit Charminar. Okay, this is the first example. Second example, I want to invest one stock. Okay, X stock. Directly, I'm not investing. What I will do? Okay, so to invest into particular task, what I am analyzing? I am analyzing past patterns of this stock. Okay, so after analyzing this stock pattern, then only I am going to invest. If any growth is there, I will invest. Otherwise, I will not invest. Here also, what I am using? I am using prediction. In real life, also we are using prediction. Later, okay, you can take any use cases. In all these use cases, we have to use prediction, weather forecasting. Okay, for visiting any new place, this weather forecasting is required. If you want to invest in any stock market, this weather for stock market prediction is required, and this one we are observing in our either Gmail, Yahoo Mail. You are seeing classification. What is the classification? Whether it is a normal mail or is it a spam? That is also coming under prediction. Okay. Now, are you getting prediction use cases? Once we understand use cases, we will learn how to design ML model. Okay. Before designing ML model, what we have to understand? Different use cases. Once you got idea about the use cases, then you will get clear idea about the ML model and how to write the program. That task will be easy for you. And after this one, then bank related example. Okay, so whether loan will be approved or whether he is having good credit score or not. This is also a prediction. Based on that, we are going to get loan will be approved or loan will be rejected. Here also what we are using? Prediction. And other one is self-driving cars. This is the trending topic now. Okay, Tesla, which is using self-driving car. There also what it has to predict? Decision for applying the brake or how to control the steering, how much acceleration is required. All these things are called as prediction or decision making. Okay, so for that also some inputs are required. Based on that input, some predictions are required for applying the brake, steering control, as well as acceleration also. Okay, so all these are coming under predictions. And few more examples also I have given. This is related to healthcare. Okay, whether one particular patient is having disease or not. There also we require prediction. Nowadays we are listening Spotify or YouTube. We are getting the recommendations. How we are getting the recommendations? Past history. Based on the past history, it is giving the recommendation. You take any e-commerce website. In e-commerce website, based on your past purchase, it is showing what you have to buy today. And the last one is for the students. How much you are studying, what attendance you have, and how you have done your homework. Based on that, prediction is coming. Okay, regarding your final exam score. Okay, all these are coming under ML model predictions. Okay, now what we learned. Okay, what we learned, definition of that ML model, we are understanding one more time with respect to these examples. Now, what I wanted to build? I want to build this algorithm based on the patterns and I want to make a decision. Now, can you correlate with all these examples? Okay, what I am taking? Data. Based on this pattern, I am predicting tomorrow's temperature. Based on stock market, stock market information, I can predict whether that stock is going to perform or not. Based on the subject and sender information, I can able to predict whether it is a spam or not. You take any scenario, what we are considering? We are considering data pattern. This data pattern is very, very important. Based on this data pattern, we can come up with prediction. Okay, now little bit idea did you get? So if you want to develop ML model for prediction, what we want? We want past data. From the past data, now you can use this past data. From that past data, you have to come up with a pattern. Based on the pattern, you can go for the prediction. Okay, these are the simple steps we have to use in our ML model. Okay, based on the examples, okay, we got some clarity. Now, I will give you one analogy. What is the reason to develop this type of algorithms? Any analogy is there behind that? Yes. What is that analogy? Our knowledge. How we are calling this is a car, this is a motorcycle. By showing this one to baby, or if you show this one to 5 years boy, 5 years girl, they can say that it is a car. Okay, by showing this one to baby girl or baby boy, they are telling that it is a motorcycle. How they can able to find it out? Because we are giving them some toys. Based on the toys, we are telling that it is a car, it is a motorbike, it is ambulance. Okay, like that, how we are teaching them. Same methodology we are giving for ML models also. So whatever human knowledge is there, same kind of how we are thinking. Okay, same kind of thinking learning pattern we are giving for ML model. Okay, so for understanding purpose, I considered this example. As a human being, I can able to say that it is a car, it is a motorbike. Whereas, consider this person, who is this one? Tarjan. Okay, if I ask this person, what is this? He cannot say. If I ask this person motorbike, he cannot say. So now what I have to do? I have make him to learn. Okay, how I have to teach? I have to tell about features of this one. At the same time, features of this motorbike. Features of the car, I have to teach him. At the same time, features of the motorbike, I have to teach him. How to teach? I have to tell him four wheels and it has a cover. Okay, then you can remember it is a car. Whereas for bike, what I have to say? Two wheels and it is not having any cover. Okay, with these two features, you can label that. It is a car, it is a bike. You can label that. Okay, so how I am teaching to Tarjan, same type of teaching pattern we are giving for ML model. Now, did you get it? Why I am giving this example? If person does not know anything about some new article, what we are telling? We are giving the features and we are giving the label. Based on feature and label pattern. Now, are you understanding what pattern I am telling? Feature and label pattern I am teaching to him. Okay, once he is ready with this feature and label pattern, he can able to predict. Okay, what he is doing, this target, now he has to predict. See this one? Now I am asking this target. Okay, like this. This is the one I am training for this Tarjan. He is learning. How he is learning? Based on feature and label. Both are synonyms. Target and label. Both are synonyms. Target and label. He is understanding the relation. Based on that relation, if you give car here, he can able to say it is a car. How he is learning that? Based on the features. Okay. How we are learning unknown thing based on our past history. Same methodology we are giving for machine learning. So that's why we are using this definition. What is the definition? Algorithm. Now I wanted to design. Okay, learning pattern from the data. What is that learning pattern? Two things are required. From the past data, two things are required. Relation between feature and target or label. Both are same. Target or label. Based on this one, he can able to predict. How Rajan is predicting, similar manner ML program can able to predict. So for ML program, what we want? We want features and target variable. This one we have to call it as a data. This one we have to call it as a data. Okay. Now, what we are observing here, this is the one. So what we require? We require step 1 is nothing but data. The data should have features and labels. From the data, what we require? It has to find the relation between features and target. So once it is learning part is over. After that, we have to test whether that person learned correctly or not. We need to test it. So how many minimum steps? I'm not saying that only 3 steps are required. How many minimum steps are required? 3 steps are required. Minimum 3 steps. Training, learning and testing. These steps are required. Okay. So this one we learned with pictorially. Now we are very good at mathematics. What is coming over here? Okay, what is this function? How to design this function? All these things are coming into our mind, right? So by seeing this, what idea you are getting? I have to find a relation between feature and target. How to find the relation? For that, known equation I am considering. Okay, to build this one, whenever you are learning ML model, always remember this equation. Okay, we learned this equation when we learned in our ninth class. Okay, so what we learned in our ninth class is not a normal thing. It is the base for our predictions. This is the base for our prediction. This is the origin for our ML model. Okay, if you recollect what we learned, this is called as linear algebra. This linear algebra equation only we are using in our linear algorithm. Linear regression. Linear regression, what is the origin? This is the one. Okay, what is this equation? Linear equation. Why we used? We used this one for drawing this type of lines. This is x-axis, this is y-axis. Okay, using this x-axis, y-axis, you can predict what could be the end point or what could be the middle point, what could be the starting point. We already predicted. That is the origin for our linear regression or linear models. So whenever ML models we are learning, what is coming into picture? Two things. What is the first one? Feature. And what is the other one? Target. Okay. So to get this relation, mathematics are required. What mathematics I am explaining? I am explaining with simple mathematics, linear equation. Okay. Using this linear equation, how ML model is going to predict, I will explain. Based on that, what are the other algorithms? Okay, algorithms are having different equations. I am explaining linear algorithm. Linear algorithm uses this type of equation. Okay, now by seeing this example, tell me what is y here, what is x here, what is y here, what is x here. Y is nothing but score and x is nothing but number of hours. Okay. This is with respect to our mathematics. With respect to ML model, what is y, what is x? And moreover, you have to observe one thing. For y, I am writing small letter. For x, I am writing capital letter, which is very, very important for ML model. Okay. So what is this y? Y, I have to call it as a target or label. Means whatever I wanted to predict, what I want to predict, that one I have to call it as target or label. Okay, this is y. What is x? X is nothing but input in mathematics. Whereas in ML model, we have to call this one as features. Here, how many features I am using? Only one feature. If multiple features are there, how our equation is going to change? Y equal to m1 x1 plus m2 x2 plus c1 plus c2. Okay. If more number of features are there, this equation is going to change. Instead of this, how we will going to write? I equal to 1 to n mi xi and ci. Okay. Like this, we are writing the equation. Okay. Now coming to ML point of view, what we are understanding? This is mathematical point of view. ML point of view, what is this one? This is x, which is nothing but features. Only one feature I am using. In case multiple features are there, you can write those multiple features. What I am predicting? I am predicting y. Now, what I want equation. What type of equation? For getting y, I have to write a equation. That equation should have x values. Okay. So, to get this relation, what parameters I am using? M and C. What is this M? M is called as slope. C is called as y-intercept form. Okay. So, how to calculate this M and C? For calculating M and C, we have equations. Okay. This x is nothing but x1, x2, x3 and so on. This y is nothing but y1, y2, y3 and so on. Okay. Now, what I want to calculate? First, I want to calculate M. M equal to, what is the formula? Y2 minus y1 by. This is not new for us. We already learned in our 9th and 10th classes. Okay, slope calculation. X2 minus x1. Okay, from this one, I am substituting these values. Y2 value and y1 value. Y2 is 60. Y1 is 50. X2 is 2. X1 is 1. Are you getting it right? Y2 and y1, x2 and x1. Okay. Now 60 minus 50 is nothing but 10. 2 minus 1 is nothing but 1. Okay. Now from this one, what I got M value. Okay. I am writing M over here. M equal to 10. Remaining values I am erasing. It's clear, right? How I calculated M? Y2 minus y1 by x2 minus x1. Now, I wanted to get C value. I already got M value. Okay, now we know y1, y2, x1, x2. Okay, now this equation, how I can write? I can write this equation like this, right? Y1 equal to M x1 plus C. So, what is x1 from this? It is nothing but 1. What is M? M is nothing but 10. What is y1? Y1 is nothing but 50. C. Now, only one variable is there, remaining values are there. So, this is 50, this is 10 plus C. Okay, now I want to get this C. C is nothing but 50 minus 10. C equal to 40. Now I got C equal to 40. So, in this equation, M and C are called as constants. Y and C are called as variables. Now I got constant values. Okay, remember these constant values. What are the values I got? M equal to 10, C equal to 40. M I am writing 10, X and C I am writing 40. Okay, this equation. Now, what we need to interpret from this one? This is our past data. You take weather data, you take what is the other one? Stock market data, you take email spam, whatever data you are considering. Okay, so what we are considering? We are considering input, set of inputs, which are nothing but features, and corresponding what I wanted to predict, which is called as target value, which is nothing but target value. So we are taking features and target values. From that, okay, we are calculating parameters. Those parameters are nothing but constants. Those constants we are finding, which is nothing but relation. Finding constant values of that equation is called as finding the relation between y and x. Okay, so how to interpret what we learned from the ML definition point of view and example point of view? What you have to correlate? I got input, I got output. Output here we are calling as target variable or label. I am finding the relation. After finding the relation, I got this equation. After finding the relation, I got the equation. What is that relation? Relation is nothing but y and x. Now, I got the equation. From this equation, what I have to do? I have to find out for the future values. This is the past data. From the past data, I got this one. Okay. Now, my son today studied how many hours? 4.5 hours. Okay. Now, I wanted to predict how much score he is going to get. How many hours he studied? 4.5, which is nothing but input. Okay. I don't have output. I need to predict. Okay. My son's score, I have to predict. So, I'm multiplying 10 into 4.5 plus 40. Now tell me how much I'm going to get. 45 plus 40. How many marks he is going to get? 85. Okay. If my algorithm is working well, okay, I need to validate that. Whatever result I am getting from this ML model and whatever result my son is getting, if both are same, I can say that my algorithm is performing well. In case both are not same, how much deviation is there? I need to calculate. Okay, based on that calculation, I need to tell the evaluation. 90% it is correct. 80% it is correct. Okay, that is called as evaluation. How to validate, how to evaluate. Okay, same thing we can apply for in all the cases also. Consider weather data. Okay, same thing. Instead of study hours, you can consider weather data. So for weather data, I am calculating humidity. Based on that humidity, I am calculating the temperature. Okay, so humidity and temperature, I am finding the relation. Now I have this information, past data information. Okay, so now what I'm going to get? I'm going to get humidity. So once I will give the humidity data, it can able to predict temperature. Same thing for other examples also. Once you have past data, it is finding the relation. Once you have given the input, it is predicting the values. Okay, like this, our ML models are working. Like this, ML models are working. Right? Very good. Good calculation. Now you got the clarity, right? How ML models are working. It's not a big deal, very simple thing. All the things we learned from the past data. Now, how we are learning ML models? We are learning ML models from the past data. Now, we are evaluating ourselves from rule-based approach to ML models. Now, I will ask you one question. Okay, you know about rule-based approaches. Rule-based approach examples already you implemented. What are the examples you implemented? Rule-based examples? Library management. Okay, students, exam score maintenance, exam score, employee payroll data. Okay, you take all these things are nothing but rule-based approach. Why I have to call it as rule-based approach? In rule-based approach, what methodology we are following? And consider example, library management. In library management, first I'll take the student ID. If it is valid ID, then only I will issue the book. Okay. So how it is different from ML model? How it is different from ML model? In rule-based approach, I am taking input. On the input, I am writing the logic. After that, I am getting the output. This pattern we are following in rule-based approach. You take any example, library management, ticket issuing, railway ticket or bus ticket, or else payroll generation. In all these scenarios, rule-based approach, this methodology we are following. Whereas coming to ML model, what approach we are taking? We are taking input and output together, right? Input and output together in step 1. Okay, input and output we are taking together in step 1, which is nothing but features and target. Then we are finding the relation. After finding the relation, we are giving input, then we are predicting the output. Whereas in rule-based approach, no prediction, we are getting the output. We are getting the output. Here we are predicting the output. So that's why we are going for whether it is correct or not. Okay, so accuracy check we are taking, F1 score we are measuring. Okay, there are different scenarios when to go for accuracy, when to go for recall. There are different scenarios. But what is important? Whether this model is working or not. So that prediction is correct or not. So that's why evaluation is also very, very important. Now, is it clear? Now, can you able to differentiate between rule-based approach and ML model? Rule-based approach, we are calculating output value. Whereas here we are predicting the output value. That is the main difference between rule-based approach and prediction. Okay. From ML model definition to what ML model is doing. You got clarity, right? If you have any doubts, please ask your doubts. If you don't have any doubts, I will go for next slide. Okay. So whatever I explained here, one more time I have written. Weather forecast, past data, temperature, humidity, rainfall, and finding the pattern, I can predict tomorrow's weather. Invest in stock X. Okay. Previous price, trading volume, market condition, all these things we are using. Okay. Based on this, we can able to decide whether to invest or not. Now, here, while we are predicting, two things are coming into picture. Whether I am predicting number or whether I am predicting label. I am telling with respect to simple uh, notations only. I am not making it a complicated values, ordinal value, categorical value. I am not using that jargon. ML jargon, I am not using simple words only I am using. Okay. So prediction again. This I am using the prediction word. Remember why I am using this prediction. Okay. In prediction, I am taking target. I am taking feature. I am predicting target or label. Remember this because this thing I am going to use in the next slide. So what I wanted to predict, either I can predict number or I can able to predict label. Okay, in case if I want to predict number, what are the use cases? I can predict tomorrow's temperature. It is a number. I can predict house price. I can predict exam score. Means how much, what exact values. Whenever you are asking questions like this, then that type of prediction is called as regression. That type of prediction is called as regression. Whenever numerical value is coming into picture. Okay. When numerical value, whenever you are asking from the data, if you are asking this type of question, how much, what exact value, then you have to call that one as regression. Whereas the second scenario is different. Predicting categories. What is the category? Instead of tomorrow's temperature, what I want to predict? Rainy, sunny, cloudy. Okay, in case I am predicting this type of values or labels, not numbers. Okay, class, category or label, you name it. Okay, it can be a category or it can be a class or it can be label based on the use case. Some names we can use it. Okay, here I am calling as category. Okay, rainy or sunny or cloudy. And what is the other one? This is important related to banks or any transaction, whether it is a fraud transaction or not a fraud. While we are using credit card, I am using credit card, it's not a fraud. My credit card used by some other person, it is a fraud. It has to be identified by my ML algorithm. Okay, whether it is a fraud, not a fraud, it has to be identified by ML algorithm. Okay, and other one, email you are getting, whether it is a spam or not a spam. Okay, then coming to this exam also, instead of predicting my son's score, whether he will pass or fail, if I can able to predict, okay, that is coming under classification. That is under classification. Labels I am classifying. Okay, which group? Yes or no? Okay, if you are from the data, if you ask questions like this, which group or yes or no? Okay, then you have to call that type of prediction as classification based on target. With respect to what I'm talking, with respect to target or label. With respect to target or label, I am deciding what I wanted to predict. If I am predicting numerical value, then it is a regression. Okay, in case I am predicting either label or class, I have to call it as a classification. Okay, now you got the clarity, right? ML algorithms which are having features and target from the data, I am predicting. Again, coming to the prediction, I am not talking about the features. I am talking about the target value. Based on the target value, In case the target value I'm focusing on how much, what exact value, then that type of prediction we have to call it as regression. Okay, based on the data and based on the target value, in case I'm classifying as rainy, sunny, cloudy, spam or not, fraud or not, yes or no, then we have to call it as classification. Okay. So now what type of values are there? Two types. Numerical and categorical. Based on numerical, we have to call it as regression. Based on categorical, we have to call it as classification. Okay. Now these are the models we have to use in our ML model. It may be logistic regression. So here you have to use target value as numerical value. Random forest classifier, gradient boost, XGB, LGB, all these are classification. Okay. And K neighbor classifier, SVM, and one more thing is also there, decision tree. Okay. Decision tree is also there. Same models, same models. If I am using for numerical value, linear regression, random forest regression, gradient boost regression, XGB regression, supervised vector regression, K neighbor regression. Here I am using for numerical value. This one I am using for classification. Categorical data. This one is for categorical data. This one is for numerical data. So only one question. Okay, that question is why these many models are coming? Why these many models are required? Based on the equation. If I am using y equal to mx plus c, I explained only this equation. Okay, similar to this, there are n number of equations. Based on the internal mathematics, these models are different. Okay, in case if I am using y equal to mx plus c and m1 x1 plus c1, m1 x1 plus m2 x2 plus c, okay, I am using that type of equation, that is called as linear regression. Whereas random forest is different. Okay, how they are different? Internal relations, whatever relation we are calculating, the way we are calculating the relation is changing from each method. Okay, this method use one type of relation, this method use other type of relation. Based on the relation, there are different models are coming into picture. Okay, only other question. This is logistic regression. But why it is coming under classification? This is logistic regression. Why it is coming under classification? Reason, this logistic regression is a classification approach. It is going to be helpful for only classification. Whatever equation we are writing here. Okay. In place of Z, okay, whatever Z I am writing, in place of Z, I am writing linear regression equation. Linear equation, or we can call that as a regression equation. As I am writing, not me, those who invented that, they used regression equation. So because of that, we are calling logistic regression. By seeing that name, don't conclude that it is a regression. Logistic regression is not coming under regression, as it is using regression equation in its denominator. So that's why we have to call it as logistic regression. Logistic regression is used for classification approach. Why these many models are there? Because of internal equation. The way it is calculating relation between features and target. Okay, they are different. So that's why these many models are there. Okay. Now what we learned? We learned so many things. Okay. Just I am revising what we learned. We learned definition. After definition, where we are using use cases, ML model, why I have to use. Okay, so our ML model use cases now we are learning. After learning ML models, how they developed this one, what analogy they use, human knowledge only. Okay, this Sargent, how he is identifying, same pattern and machine learning models are also using. And for that, what we understand, they required input, finding the relation. Based on that relation, we need to find out ML models, different ML models. Based on the target, this type of ML models are there. Okay, now what we have to do? Till now we learned about ML model. Okay, now this is the time for writing the program. So for writing the program, whatever theory we learn, that theory we need to make it into a practical approach. For making it to practical approach, what is required? We need to understand the steps. See, suppose if you want to cook noodles, directly are you eating that noodles? No. You have to follow some steps, right? You need to cut that noodles, you need to switch on, water is required, add the noodles, some steps you are following. Here also, if you want to get ML model output, using programming approach, you have to follow some steps. What steps are required here? First, you need to understand the problem. Really, am I going to apply prediction or not? Or is it coming under rule-based approach? What is this one? You need to identify. Then, you need to analyze the data. This is very, very important. Analysis of data is very, very important. After analyzing, we are giving input to that model. So, before giving input to the model, you need to make that data is suitable for ML model. What we have to do? That data must be suitable for my ML model. So this pre-processing is very, very important. After that, our ML models are predicting the outputs. So you need to evaluate. So whenever you are developing ML models, these are the mandatory steps. First, you need to understand the problem. What are my features? What is my target or label? Then you have to understand. So can I apply ML model or not? After that, you have to understand the data. After understanding the data, you have to make the data suitable for ML model, pre-processing. Then why modeling is required? Because n number of ML models are there. Okay, so what I have to do, which ML model is suitable for this data? By seeing this data, I can't say, okay, this data is suitable for ML model. We need to consider some set of ML models. Out of those ML models, which ML model is suitable for my data? At the same time, with analysis, you have to say, this data is working very well in SVM. This data is working very well in random forest. For this analysis, this modeling is required. After that, analyzing the result. These things are very, very important for our ML model. And yes, here I am using one word, supervised learning. Whatever example I am covering here, okay, that example is coming under supervised learning. Okay, this class I am targeting on supervised learning. Okay, I am not targeting on unsupervised learning. Reason, here I am considering feature and target. If your data consists of feature and target, and if you are predicting the target, then you have to call that one as supervised learning. Whereas, if you are having set of features are there. From these features, if you are making into groups, then this is not having any target value. Set of features are there. From the features, if you are making into groups, that one we have to call it as unsupervised learning. I am not explaining unsupervised learning in this class. I am explaining only supervised learning. So now, what I am telling, previously I told you, right, you have to remember feature and target together. Feature and target together, you have to remember. Feature and target, you remember it, right? So whenever you are combining feature and target together, if you want to predict the feature, sorry, if you want to predict the target or label, that type of algorithm is called as supervised learning. Okay, so in this class, I am targeting supervised learning. Okay, now I am going to code. Okay, so here I am explaining with respect to steps. Okay, I am explaining with respect to steps. It's visible, right? Please confirm. Yes, I got confirmation. Okay, so here I'm not using Jupyter, I'm using Google Colab. Whereas I'm not explaining Python code in detail, Okay, in case if you want in detailed explanation of Python code, please write it in the chat. Okay, please write it in the chat in case if you want in detailed explanation of Python code. Here I am explaining with respect to the steps ML point of view. In case if we want to, if you want detailed explanation of Python code, please mention in the chat. Okay. Now, my what I'm targeting? I'm targeting data. So, where can I get the data? I'm not taking synthetic data. You consider students, consider research scholars, consider IT professionals. You are getting real time data. Okay. So, you have to take the real time data. Now, I'm taking this real time data from the CAG. I am taking this real-time data from the Kaggle website. Okay, I will give you that description also what data set I am taking. Okay, so in case if you have account in Kaggle, well and good. Otherwise, create the account. For creating account, you require your mail. From that mail, login. After login, at right side, you can see the settings. Click this one. Go to settings. In that settings, whenever you want to use the data set, I'm telling the steps. Okay, I'm telling the steps whenever you want to download real-time data, whether if it is for any participation also, any participation also, you can get the Kaggle, or if you want to work out on ML models for practice purpose, you can use Kaggle data. They have real-time data. Okay, so here, if you want to use data from here, you already I have a token. What you have to do, you have to click this one. Once you click, it is going to generate the token. It is going to generate the token. It will be downloaded. That token is in a JSON format. That token will be in a JSON format. Okay, that token you need to upload. Then only you can able to access Kaggle data. Okay, so if you want to access Kaggle data, you have to give the permissions. So for that permission, first I need to install Kaggle. Okay, this step is for pip install Kaggle. This is for using Kaggle account in my Google Colab. Now I got a secured connection with Kaggle. Now what I have to do? I have to upload Kaggle JSON. Whatever token I downloaded, I have to use that. This is the token JSON format. Once you click that, it will be available. Now secured connection formed between my Google account and Kaggle. Okay, from this Kaggle, what I have to do, whatever I am downloading, I have to give the permissions. I have to give the permissions, read write permissions I have given. Now I am downloading the data set. Here I am not explaining credit card, employee data, student data. I am not taking. I am taking missionary data. I am taking missionary data. That data I am downloading. Predictive maintenance of missionary data I am downloading. Okay. Here it got downloaded. Where it will be? It will be in Google Drive. If you click here, you can see. This is my data. Okay. It is there in .csv format. Now I wanted to see the data, whether data is loaded or not. Okay. So what steps I completed? I established secured connection to the Kaggle. After that, I have given read write permission to that Kaggle account. Then I downloaded the data. After downloading the data, then I want to use the data for my ML model. So what I have to do? I have to store my data into data frame. I have to store that data into data frame. I already showed you, right? This is the data. Where it is? It is in our Google account. It is in our Google account. Here it is. Okay, see this one. It is in my content. This is the location. From this location, I am downloading .csv file. Where I am downloading? I am downloading into data frame. Now, my data frame consists of my data set. Okay, whatever data we are learning from the beginning of the class, data we are talking, right? So now I am taking this data. Where I am using? I am using the data in my Google account. Okay. So using Google account, using Google Colab, using Python program, I'm writing the code. Okay. So now data is available. Okay. Now I wanted to analyze this data. This data is here. This is the data. Okay. So what is this data set? sensor readings from industry missions. Okay. So why it is required? Once we understand the feature, you can able to understand. Observation of missions operations. Why prediction is required? Because whether that machinery is working properly or not. In case any damage may come in the future, I wanted to stop that damage. Why prediction is required? Based on the prediction, I can stop that damage. Okay. So numerical sensor data I'm taking. Temperature, speed, torque, tool wear. Okay. Missionary type. All these things I'm calling as features. Based on this one, what label or what target I'm getting? Failure label. I'm getting this one as failure. Now I have input, not single input, multiple inputs. Those multiple inputs I'm calling as features. Those multiple inputs I'm calling as features. After that, based on this sensor data, I wanted to predict in the future this machinery is going to fail. I wanted to predict. That is called as failure label. So now I have features and target. Now I can apply supervised learning. Okay, so what I wanted to predict? Mission failure. Okay, predict whether that mission will fail. Okay, in the during operation. Okay, it should not fail. So what is my motto? It should not fail in the future. Currently only in the present situation, I wanted to predict to control the damage. So for that, these are the features. These are the features are there. What is that? One is called as record ID, product identifier, type of the object, okay, and air temperature, process temperature, rotational speed, torque, tool wear, machinery failure. Okay, this machinery failure is called as whether it is going to fail or not. Okay, so here one important thing is there. I am taking whether it is going to fail or not. Whereas here it is a binary target. Instead of binary target, if you want to use based on one particular item, based on one particular item also you can able to predict, or set of items. In case if you are considering set of items, then it is called as multi-class classification. I am not going for multi-class classification. I am going for binary classification. Okay, so that's why in my program I am not using last 5 features. These features I am not using. Just I am using whether that machine is going to fail or not. These features I am not considering. In case if you want, please write it in the chat. Multi-class classification regarding in case if you want class, please write it in the chat. Multi-class classification we are going to cover. Okay, these are the features and target. Now you got the clarity, right? What are the features? These are the features. And I am taking only binary target. I am not considering this one. Okay. For multi-class classification, we will consider that. Okay. I am not considering that. Binary classification only I am considering here. Okay. So these are the features. Now we have to start our analysis. We have to start our analysis. How to start the analysis? For starting analysis, we already know that we need to understand the data. After understanding the data, we have to pre-process the data. After pre-processing, models are required. Okay. So for that, I am using Python. Okay. Python is user-friendly, programmer-friendly. So no need to write the logic. For everything, we have a corresponding package and corresponding class. Okay. In this class, I am not explaining all these things. Just I am telling that what are the required packages, what are the required functions you need to import. Okay, what are the required packages and what are the required functions we are importing. Okay, for that I am using scikit-learn. For that what I am using? I am using scikit-learn. Okay, now I am copying my data. Data is available. So how the data is available in my data frame? I am checking only first 3 rows. What is the pattern of data available in my data frame? I am checking here. Only 3 rows. In case if you want to see other rows, you can click here. It is going to be available at right side. Okay. Whereas, is it there in my data frame? I don't want to see the complete data. First 3 rows, I am checking. Now, it is the information about the data. Okay, what is this information it is telling? Very, very important for us. Here, it is telling how many columns are there. How many columns are there? It is telling. These are the columns. Whatever columns I displayed over there. How many columns? 14 columns are there. And how many rows are also there? Here it is telling. How many rows are there? 10,000 rows. First row ID is 0 and last row ID is 9,999. So total number of rows are nothing but 10,000 rows are there. So 10,000 rows. What you have to assume? Assume it is like a Excel sheet. This pictorial representation is required. How many rows are there? 10,000 rows are there. How many columns are there? 14 columns are there. This type of data set we are giving input to our ML model. Okay. So which consists of features and target. From these features and target, our ML model has to learn the pattern. Once it is ready with the pattern or relation, we can give input related to the feature. Feature is nothing but missionary feature. Then you can predict that mission is going to it is going to create a problem or it is not going to create a problem. That one you can able to predict in the future. Okay, now you got clarity about the data set. Now data set is ready. Okay, as I'm downloading data from Kaggle or somebody might have entered the data. So what we have to find out, the first thing we have to find out, finding the thing is any null values are there or not. What is the first one? Null values. So null value count you have to use is NA. Is NA stands for any null value is there. If any null value is there, it is going to return the true. Okay. This function is going to calculate true and corresponding sum. How many trues are there? It is going to calculate. Is NA dot sum indicates how many null values are there. If null is present, it returns the true. How many true values are there? It is going to calculate. Okay, if null values are there, we need to, what step we need to follow? That part I'm not covering. That part is called as EDA. Please write down in the chart in case if you want the class on EDA. Okay, in the EDA, I'm going to tell you missing values. If missing values are there, what are the steps we have to follow? In case missing values are there, what are the steps we have to follow? Whether to replace with any other value or I have to remove that row. Okay, some different strategies are there. What strategies we have to follow? Please please write it in the chat. Okay, so luckily our data is not having any null value. Okay, in case null value is there, for numerical value separate logic, for categorical separate logic is there. Okay, luckily we don't have any null values. In case null value is there, okay, because I always follow one template. Okay, using that template only I am explaining. So first what I have to do, I identify, I have a data. That data consists of features. I'm talking about the features. In the features, how many numerical values are there? How many categorical values are there? I need to find it out. Okay, where can I get this information? I'm using word information, right? So which function is required? Info function. Info stands for information. Okay, information of the features. Where can I get? Using info function. It is giving. Here data type is there. Okay, based on the data type, you can able to get it. Integer, float, wherever you are getting integer, float, all these things are called as numerical data. Okay, whenever you are getting object, that object is called as categorical data. Categorical in the sense, it is in a English word format. It is in a English word. Okay. So, what I have to do? Whereas for numerical values, we can apply mean, medium, some strategies are there. Using these strategies, you can replace. What about categorical? For categorical, mode operation we have to use. Why mode, why mean, when to go for mean, when to go for median, all the things. If you want, write down in the chart. That will be covered in the EDA class. If you want EDA class, please write it in that chart. Okay. So here, So what template I am telling? I am differentiating object and category. Okay, object and category I am differentiating. Categorical data I am writing here, numerical data I am writing. Whatever info is there, from that info I am categorizing my data, categorical columns and numerical columns. So analysis on numerical columns is different, analysis on categorical columns is different. Okay, now what I have done, I copied numerical columns here and I copied categorical columns here. After that, wherever missing value is there, I am replacing missing value with median for numerical data. Okay. Wherever missing value is there for categorical, I am replacing with mode. Okay. So you follow same template. You also follow the same template. Okay. Again, after that we need to check it out. Okay, any null values, I told you, right? If null is there, it is going to return true. If null is not there, what it is going to return? False, it is returning. Okay, after that, also after replacing null values, again I am checking. Again I am checking. Now, what I have to do, I told you, right? I don't want to use these 5 features. I don't want to use these 5 features. I am removing. At the same time, I don't want to get any relations, okay, with this product ID and UDA, because can we get any relation with respect to UDI and product ID? Those are unique values. Unique values are not required. This is the standard strategy in ML model. Wherever unique values are there, you have to remove that unique values. UDI and product ID, I am removing. I am not targeting on multi-class classification. I am dropping these values. So these things I am storing in the list. That list I am passing to this function, drop function. It is going to remove that. Okay. So wherever target is there, I am checking the target is there or not. Now I categorized into Y and X. Okay, X and Y. These symbols I am going to explain in the next cells. In the coming cells, I am going to explain that. Okay. Now, after differentiating, next what I have to do? I have to analyze my numerical data. What is the next one? After understanding the data, you need to analyze. Numerical data analysis is different. Categorical data analysis is different. For numerical data, general thing we have to check, because we are applying ML models. ML models assumes data is following uniform distribution. Data is following uniform distribution. So that's why what we have to check, whether numerical data is following uniform distribution or not. Why we are checking? ML models assume whatever data it is taking, it is following uniform distribution. Okay. So, in case data is in uniform distribution, it can come up with good relation between feature and target. If data is not following uniform distribution, it cannot predict properly. So, that's why what we have to identify for numerical data, whether it is having uniform distribution or not. Okay. So, that part I am checking here. Okay. So, for that, uniform distribution, numerical data, numerical data, uniform distribution, how I can able to get normal distribution or uniform distribution? Using histoplot. Using histoplot, if you want that bell curve, this curve, if you want, you have to write KDE. What is this KDE? KDE stands for kernel density estimation curve. Otherwise, just it is going to give this histoplot. Means what is within the range, how many values are there? I think everybody knows that histogram. Histogram consists of range. Within the range, how many values are there? It is going to plot this. Okay. On top of that, whatever plots are there, on top of that, if you want this type of line, okay, this line is called as kernel density estimation. Then you have to write KD equal to true. How many bins means how many histogram plots you want, you have to write it over here. Why it is required? If data is there in uniform distribution or not. Okay. Now, why they are considering uniform? Because ML models thinks that every data is in uniform distribution or normal distribution. Related to normal distribution, uniform distribution, it is part of EDA. Okay. So here I am checking this. Okay. This is not in a bell curve format. See this one? It is almost in a bell curve format. Here It is actually bell curve has to be there at the middle. Bell curve has to be there at the middle. Here it is not there at the middle. It is skewed towards left side. This one is called as skewed towards left side. And see the last one, dark NM, it is following bell curve. And what is the last one? Total weight distribution. Here also it is not following normal distribution. By seeing that, you will get at the same time, if you observe this code, here I have written a p-value calculation. Okay, based on this p-value calculation also, we can able to get the idea. Is it following normal distribution or not? Using visual representation as well as statistical distribution also. Both the things we are verifying. Okay, based on p also, we can able to get it. Okay, so what is the range? If p greater than 0.05, we can say that it is following normal distribution. Whatever p we are calculating, if this p greater than 0.05, we can say that it is following. One minute. Yes. Yes, these are the values. See, these are the values. Wherever p greater than or equal to 0.05 here, it is following normal distribution. Other cases, it is not following. Okay. So, from this, what analysis we got? According to ML, cutoff is greater than 0.05. Which one is passing the exam? Dark NM. Others, they are not passing that exam. They are not in a normal distribution. What to do? You have to transform that. I'm not changing the data. We have to transform. Okay. Why I have to transform? ML is assuming that data has to be there in normal distribution. We are converting skewed data or non-normal form into normal form. Not changing the data. We are changing their methodology. Okay. Simple example I will tell you. Take this one. I have this data 1, 5, 10, 12, sorry, 1, 5, 10, 100, 500. This is the data. Okay. Instead of representing in this format, same data, which format I am taking? I applied log transform. Same data. Instead of taking in this range, okay, instead of taking in this values, in this range, what range I am taking? This is the range. I am not changing actual meaning. Instead of representation, instead of this representation, log representation I consider. There is no change in the data. Only representation we have done. What is the meaning of that? We preserving the same data. Only scaling and shape we are changing. Why it is required? Because I wanted to represent instead of in this format, I wanted to represent here. Take this one 1, 5, 10, 100. 1 will be here, 5 will be here, 10, 100 and 500. See, what is the range? Instead of this range, we reduced the range. So, what is going to happen to our data? Instead of taking in that wide range, it is coming into small range, and wherever skewed data is there, it will be coming in that small range. Okay. So, this is called as transformation. This is called as transformation. Why transformation is required? For preserving the same data, only scale and shape. Okay. For that purpose, we have to apply transformations. Okay. Either you can go for log 1 plus log transformation or power transformation. Okay. Here, I am not using 1 plus log transformation. I am using power transformation. Okay. Here, Johnson power transformation I used. Okay. Now what I am getting? I am getting the same data in a other format. Just we changed the shape of the data. Instead of skewed data, we are getting in a normal data. Okay. Now our ML models can understand my data. After transformation, I have to execute this one, right? I executed this part. Now I have to convert, which is not there in normal distribution. Now I am converting into normal distribution. After normal distribution, what I have to do? Again, I need to check the information. After checking the information, any Okay. Now I have to go for 1 minute. Let me execute from the beginning. Data is there. Okay, meanwhile, I'm going to answer questions in the chat. Some person is asking about synthetic data. Synthetic data in the sense prepared by us. Okay, prepared by us. Which is not a real data. I can cook my data. Okay, so that data is called as synthetic data. Categorical data I differentiated. I copied here. After copying, histogram. After histogram, then skew transformation we have done. After skew transformation, again one more time I am checking. Model information I am displaying. Yes. Okay. Now, numerical data we completed. Just I will give 1 minute time. Any doubts in case if you have, please ask your doubt. Okay. Now coming to categorical data. So only one category is there, which is nothing but model type. Now from this model type, you have to see how many values are there. Okay. So that part I am calculating. There are three types of models, large, medium, high. Okay. What is their percentage I am calculating? 60%, 30%, 10%. Okay. Here, this data we can say that distributed. Okay. This data is distributed. Okay. When we can say that this data is not distributed in the categorical if either any one of these category is coming under 1% or 5%. Or you can say that within this range. If data is there 1% to 5% range, then we can say that our categorical data is not distributed properly. Whereas for numerical data, we can say that we can go with uniform distribution. Here, for categorical, we don't have any uniform distribution. Just you need to calculate their percentage. How much percentage it got occupied in the data? 60%, 30%, 10%. When we can say that it is not distributed properly, if it is in the range of 1 to 5%, it is not distributed. Then we have to follow other things. Either you can combine M and H or L and M. We can combine. Okay, that strategy we have to follow. Here, no need to combine any data. Just you need to take simply L, M and H together. But this data is in which format? It is in categorical format. Whereas my ML model is finding the relation among numerical data. It is finding the relation among numerical data. If I give categorical data, how it can able to find the relation? It cannot find. So what you have to do? You have to convert categorical data into numerical data. Okay. Here I am applying one hot encoding. Okay. Here I am applying one hot encoding. Okay. You can go with one hot encoding. In that one hot encoding, what methodology I am finding? I am using M and L, MLH I am finding, right? So ML I am using, H I am dropping. I am not using H. Just I am using one hot encoding means I will give values for L and M. By using values for L and M, obviously I am going to get value for H. Okay. So take this example. This is the function you have to call dummy function. In that dummy function, whatever types are there, you have to call that type function, which is nothing but feature. And I'm converting categorical into categorical in the sense object. Object into integer I'm converting, and I have to concatenate. I have to concatenate, and I need to make it into that data frame. So these steps I followed. These steps I followed. Now I have L and M. What about the H? I will tell you that. L, M, H, L, these are the types. L should not come into picture. In place of L, some value has to be there. In place of M, some value has to be there. In place of H, some value has to be there. Okay. Here, what are the values I wanted to use? L and M values I wanted to use. Okay. So, type M and type H I will take. So, whenever L is coming, 0 will be there. Whenever M is coming, in place of M, 1 is coming into picture. In place of H, 1 is coming into picture. Whenever L is there, 0 will be there. Right? Now, are you understanding? Instead of getting 3 columns, we are getting only 2 columns. One column I am dropping. Dropping in the sense, whenever L is coming, I will write 0, 0. Whenever M is coming, I am writing 1, 0. Whenever H is coming, I am writing 0, 1. Okay, now you got the logic, right? What one hot encoding is following internally. Okay, 3 values are there. So, we are expecting 3 columns. 3 columns are not required. Only 2 columns I am taking. What are those 2 columns? M column and H column. Whenever M is coming, it is representing as 1, 0. Whenever H is coming, it is representing as 1, 0. Whenever L is coming, it is representing as 0, 0. Okay. So, by this method, we can drop one column. We can reduce one column. Okay. So, like that, we converted L into 0, 0, M into 1, 0, H into 0, 1. So, in our rows, wherever M is coming, it will be replaced with 1, 0. Okay. Whenever H is there, it will be represented with 0, 1. Wherever L is coming, it will be represented with 0, 0. Now, our ML model consists of only numerical values. Our ML model consists of only numerical values. Okay. Now, we completed numerical analysis, categorical analysis. After that, again, I have to execute my data. Okay, information. 2 more columns got added. Now, type is not there. In place of type underscore L, type underscore M. Okay. Now, this is about our data. Now, one more thing also I added here. Okay. So, I am taking only these features. From these features, can I come up with any new additional feature, any derived feature? You can call that one as derived feature. Okay. So, if you analyze the data, you will get that understanding. You need to speak to the data. If you speak to the data, okay, you will get any feature engineering is required. Here, just I used small logic. What is that logic? Whenever that particular machine is running, okay, it is generating the heat. Okay, outside heat, process temperature, if I subtract, if more temperature is there, then it is consuming more energy. In the future, it may get failure. That logic I applied. Just I used environment, physics I used. Just physics I used. Process temperature, outside temperature. If process temperature is high and air temperature is high, okay, if I subtract, if it is not in the normal temperature, if it is not 30 degrees, if it is more than 30 degrees, then some harm is going to happen to that machinery. I applied that one. And again, physics, torque and rotational speed. Okay, I calculated power also. Okay, so what could be the power of that machinery? I calculated. Just I multiplied torque and rotational speed. Okay, just I used physics. Okay, according to the data, what you have to apply. Okay, so just we need to apply the environment. You have to understand the machinery, what type of features are required, additional features, or you can call it as a derived features. Okay, so understand those features, create those features. For creating those features, complicated logic is not required. Simple mathematics you need to apply and derive the features. Okay, I derived these features. After deriving this one, I got additional information. Type L, type M on top of that, 2 more things. See, till here 7 features are there. Now 2 more features got added. I am giving one assignment to you. What is that assignment? New features I calculated. They are numerical features. Okay. So, for numerical feature, what you need to identify? Uniform distribution. I followed this uniform distribution. Here, it is somewhat uniformly distributed, whereas it is right skewed. I have not transformed. Okay. Whereas, as an assignment, you transform that. Okay. What you have to do? Apply log power transformation, sorry, power transformation, apply power transformation and give that feature to ML model. I have not done that. As an assignment, you have to do that. Okay. Now, this part also I completed. After that, what I have to do? I have to find out the relation. Okay. So, we are calculating relation between features and target. Really, this feature is going to be helpful for predicting the target or not. You need to find it out. So, how to find out? Using correlation. Okay, using correlation, what you can able to understand, really that feature is contributing for predicting the value or not. You need to identify that. For that, we have a correlation. Okay, if it is a strong correlation existed between feature and target, then that feature contribution is there for prediction of the target. Otherwise, that feature you need to drop. Okay, so what do you have to follow? You need to find out the correlation between feature and target. High correlation is there between feature and target, include this feature. Low correlation is there, you need to drop that feature. It is not contributing for prediction. So that's why this correlation is required. When correlation is required, if you observe this program, after reading the data, we identified null values. We replaced the null values. After that, we analyzed numerical values and categorical values. After analysis, any changes are required, we added those changes without changing the data, just scaling transformation we have done. Then we modified the categorical data. We converted categorical into numerical. Before giving this data to ML model, what you have to find out? Correlation. You need to find out that correlation. High correlation has to be there. So for that, just I call this correlation function. I'm executing. Now I'm getting these values. Correlated values I got. How to decide? Do we have any methodology or do we have any metrics to decide? Yes, we have a matrix. What is that? This is the one. High correlation is called as -1, 1. Okay. Strong correlation plus -5 plus 5 medium correlation. If data is plus 2 is also weak correlation. -1 0.1 minus 0.1 0.1. Okay, either this one or this one. This is called as very weak correlation. Okay, here I forgot the table. One more table is also there. Okay, that table gives these values. If data is -1 or 1, strong correlation. If data is in between -0.9 to 0.5, plus 0.5 to plus 0.9 to plus 0.5. This is called as moderate correlation. Then minus 0.3 to minus 0.2 is called as weak correlation. Okay, next range is called as very weak correlation. Okay, we have a range. Based on that range, we can decide, okay, whether to include that feature or not. Now, these are the values we got. Based on this, we are giving this one. Weak, moderate, weak, very weak, negligible. Okay, we got this one. Here I applied because as I have very less features, I am applying. Whereas whenever you have a large features, remove these weak features. Remove these weak features. So based on the correlation, you can able to get that relation. Once that relation is ready, now actual thing is coming into picture. What is that one? Today's topic, ML model. So directly we don't have an option to give our data to our data to ML model. Our data has to transform through all these phases. Our data has to transform through all these phases. Okay. So while it is transforming through all these phases, what we have done? Null values removed, numerical values analysis, categorical values analysis, categorical conversion, correlation calculation. Now we are giving our data to ML model. Here, very important concept. Okay, so what is that? I wanted to test that ML model, right? So whatever data I have here, 10,000 rows are there. Here 10,000 rows are there. This 10,000 rows I am dividing into two parts. Okay. First part I am calling as training. Training is for understanding the relation, finding the relation. After that, remaining part I am giving for testing. Remaining part I am giving for testing. Why this testing is required? I want to validate because ML model is for the prediction. Okay. So whether that prediction is correct or not, how to test it? For that, whatever data I have, the data I am dividing into two parts, training and testing. Why training is required? For learning. Why testing is required? For validating the result, testing is required. Okay. Now here also whatever uh, packages are required, those packages are imported. After that, observe here, I told you, right? For features, capital X is required. For target, small y is required. Capital X. For that, just recollect your set theory. Okay, whenever we are understanding set theory, set we are identifying, set we are representing with capital letter. And whatever elements are there, those elements we are writing with small letters. So, from this, what we need to interpret? It is a set of features. This X, even though it is representing one variable, internally it consists of set of features. Okay, so that's why we have to write capital X. And next one, Y, only one target value. So that's why small letter Y. So whatever features are there, those features we are storing into this X, and Y is target. We are writing here. After that, what I am taking? I am dividing my data. See this one, very important function for ML model. Train, test, split. This function is required. What is the meaning of that? Whatever data is there, I am splitting my data into two categories, training and testing. How much is required for training? How much is required for testing? If you observe this one, test size 0.2 means test should store 20% data, train should store remaining data, which is nothing but 80%. Okay, test size 0.2 if you write, testing is going to store 20% of data. Here, as I have 10,000, so 2,000 rows are coming over here, 8,000 rows are coming into training. Okay, so I am dividing like this. Okay, every time it has to divide same set of rows for training, same set of rows for testing. What is the clause I have to follow? Same set of rows for training, same set of rows for 2000. That same is very, very important. Randomly it is giving some set of rows for training, some set of rows for testing. It's not a correct way of writing the program. How can I open my system? Can I see that? Not possible. Using only one number, it is going to possible. That number is called as 40. That number is called as 42. If you write 42, if you execute this program n number of times, same set of rows will go to training, same set of rows will go to testing. Okay. So why that 42 I have written here? One humor is there for 42. Okay. Now we are going to get a data. Ma'am, is it a standard one? 80-20, 70-30 or any other combinations are there? Generally, we are going to follow two strategies. Either you can go with 70-30 or 80-20. When to go for 70-30, when to go for 80-20. 80-20 when we have to use if data set is very large. If data set is very large, you can go with 80-20. As I have a large data, 10,000. Suppose I have 1,000 rows. Then I will go with 70-30. Can you guess? Because I am going to get 700 rows over there, 300 rows over for testing. As I have large data, so I can give more information for my training. So 88,000 rows I am giving here and 2,000 rows I am giving for training. Okay. Less for testing, more for training. For a good if data set is large. Whereas if you want strong validation for small set of data, then 70-30 is required. Okay, this is the standard strategy. Why 42? 42, yes, here I have written. See, random splitting can give different training and testing. Okay. So if you write 42, setting random state, fix the randomness. Okay. You are going to get same values. Okay. So why this 42? Mostly humorously in Medium Digest they have given this one. From this Hitchcock Guide to the Galaxy, they are calling this 42 as called as answer to your life, the universe and everything. Okay, so 42 they defined like that. But randomly they considered, but it is correlating with this one. So humorously they are telling that as 42 is a universe number, it is working for our ML model. Okay, so 42 why? Because same, even though it is random, I want to get the same fixed number of values for training and testing. Okay. Here this part is over. Here from this part some pictorial representation is very important. What is that pictorial representation? This one. I told you, right? We have Excel sheet. I am dividing my Excel sheet into two parts. What is the first part? First part is called as training. Second part I am calling as testing. Okay. Then I am dividing. This is X, this is Y. Now, what I have to write this one? X underscore prime. This one I have to write Y underscore prime. Okay, this part I have to write X underscore test. This part I have to write Y underscore test. Remember this one. These four variables are very important. How many variables I am getting? These four variables. If you pass this data X and Y to this one, how many values we are getting? These values. Okay, this is first 8,000. This is last 2000 randomly. I am telling first 8,000. It could be anything. Okay. Set of 8,000 values, set of 2,000 values. So 8,000 values got divided into two parts, X train and Y train, X test and Y test. Remember that. Okay. Now, what we have to do? Now, I have to pass training data, testing data. When training data is required for making that equation. How to make that equation? Okay. So for making that equation, we require models. So I am storing my models here. Okay. Here, models I am writing with their hyperparameters. Okay. These are called as hyperparameters. Okay. Simple analogy is there for hyperparameters. Suppose if you have a washing machine. Okay. Washing machine, what you have to do? It has to clean. Okay. Okay, that is called as its parameter. It has to clean those clothes. Okay, whatever buttons are there, wash, spin, and uh, temperature and water level, different buttons are there, right? Those are called as hyperparameters. Those are called as hyperparameters. To smooth work of this machine, these parameters you have to set. Those parameters are called as hyperparameters. Okay, what is ML model? ML model has to predict. So internally what it is calculating? M and C. To calculate M and C, some parameters you have to set. Those parameters are called as hyperparameters. Here we have to follow two strategies. Okay, suppose if you are executing n number of programs, you will get some expertise. With that expertise, you are going to set these parameters. Or else, what we have to follow? You have to follow grid search algorithm or random search algorithm. There are different algorithms are there. Using those algorithms, you can tune those parameters. You can tune those parameters. Whereas general strategy, I am following this strategy. For my all ML models, I am following that strategy. I am using those parameters. Whereas for fine tuning this one, I can use either random CV or grid CV. Different approaches are there. Using that, I can change those values. Okay, now you got the clarity, right? Hyperparameters are nothing but whatever values it is learning internally. To get proper values, these parameters you have to set. Okay, standard template is there. From the template only I am taking. In case if you want to set those values, you can use other algorithms are there. Okay, hyperparameter tuning algorithms are there. Using those tuning algorithms, you can apply that. Okay, models. So first I designed my models. Okay, then I wanted to store the results. I'm storing the results. Now what I have to do? I have to get that equation. For getting that equation, What parameters I am taking? X train and Y train. Okay. Then this is the model. Model dot fit. What I am writing? I am writing model dot fit. See this one? It is a set. So that set I am calling here. I am calling this set. It is storing name over here, model over here. So initially it is calling logistic regression. So logistic regression dot fit. Now what it is finding? Whatever equation is there for logistic regression, in that equation it is calculating its learning parameters. It is calculating learning parameters. It is finding that equation between y and x. To find that x relation between y and x, we are calling this fit function. Okay. So that fit function, what values it is taking? Training values. Those values are nothing but 8,000 values it is taking. Okay. So why it is required? For finding the relation between y and x. Okay. This is the one we are passing. What values we are passing? Train values we are passing. Okay. Now relation is ready. Model fit. After that, you need to predict that value. For prediction, what I have to call? I have to call testing. Okay, I am passing testing. Okay, I am passing testing. What I am taking? I am taking prediction value. See, one more parameter is adding along with those four parameters. One more parameter is adding along with that four parameters. Just a minute, I will show you. Okay, it's not coming. Here I will write it. So, X try, Y try. And X test, Y test. On top of that, okay, we are getting one more parameter. What is that parameter? Prediction parameter. This training we are giving for model fit, for learning the relation. Now I am passing this test for prediction. Okay, if I pass this text, what I am getting? I am getting prediction value. Now what I have to find out? Just think and analyze what I have to find out. Whether this predicted value, testing value, both are same or not. If both are same, it is 100% accuracy it is giving. Any deviation is there. Based on the deviation, only we are getting 90% it is working, 80% it is working. So, evaluation, what we want is prediction. Okay, for finding the evaluation, what we want prediction, Y prediction, Y test. Based on Y prediction and Y test, we have to go for evaluation. Okay, now you got it right. Whatever we learned, pattern we are identifying. For pattern identification, training is required. After finding the pattern, we need to predict the value. For that, we are giving the testing. After testing, we are getting the prediction value. After prediction, see this one? I got Y prediction. Now I am comparing with Y test. Now I am calculating accuracy. Here I showed only accuracy. Okay, so how I am writing accuracy? See this one? I am writing accuracy like this. Okay, functions are also there. Functions are also there. Your task is to find out what are the functions for accuracy, precision, recall and F measure. That is your assignment. Okay, with this accuracy, I am showing the result. Accuracy and F1 score I am representing here. 86% accuracy is there. Here 97% accuracy is there. 98% accuracy is there. Okay, for each and every algorithm we are getting. Now, what to analyze? Which algorithm performance is good? Okay, based on that you have to decide. See here, logistic regression is giving 86, decision tree is giving 97, random forest is giving 98 and SVM is giving 83. So, which is winning over here? Random forest. Most of the cases, random forest is giving proper result. Well, if you give proper parameters, if you give proper hyperparameters, if I change these parameters, instead of estimator 300, if I give 500, it is not going to work properly. Okay, so with this so much of permutations and combinations, I got this result, random forest. You observe most of the times random forest is giving, because internally it follows pooling methodology. Internally it follows pooling methodology. So that's why random forest is giving best result. Okay, we need to analyze that result. That analysis is different for different scenarios. Suppose if you are a research scholar, what you have to do? Statistically, why it is significant? Okay, what it is proving, what it is disproving, what are the p values are there? Okay, what I want to reproduce properly, what I have to validate. Then peer review and publications, based on that you have to go for publication. As a research scholar, you have to analyze your data in this point of view. In case if you are an IT professional, you have to think in this direction: business impact and ROI. And after that, can this be deployed? Okay, what are the performance metrics? What is the cost? This one you have to make it into a report. Scalability point of view and maintenance also you have to consider. Production deployment. These things you need to consider. Suppose you are an engineering student, you have to understand the concepts, why it is working, why it is failing. You have to write proper report with learning outcomes and insights. Okay, you have to consider theory versus practical gaps. Apply to the new problem. You have to think result according to where are you sitting. Okay, so result analysis is very, very important. So here we got the result. Here which one is winning? Random forest. Okay, this data set, what we have to conclude? This data set is giving better result for random forest. Okay, only one question I am asking, think and write down in the chat why random forest is working in this scenario. Why not SVM? Okay, that's it from my side. Uh, for more details, if you want more details about this one, you can go, you visit this website, and one number is coming in that chart. You can send your details to that number regarding more details of this data science course. And in case if you want this IPYNB file or PPT, if you want, one number is there in that message. Send hi to that message. Send your request to that to that number. You are going to get your IPYNB file and whatever presentation is there. You can work on this IPYNB file. Thank you all for patience listening. Happy learning.